Hi, in this video, I will be talking about the different types of random variables, and also I'll show you guys some examples of that involve random variables. In the previous video, I talked about what random variables are. If you're not sure what random variables are, please watch the previous video. Okay, so let's get started. We have two types of random variables. The first type is called discrete. So in the previous video, all the examples that I gave you guys, they are actually all discrete random variables because we can count the random variables, right? So for example, number of heads when we flip the coin twice. That was one of the examples I gave you guys in the previous video. We can count. I have 0 head, 1 head, or 2 heads. Right? Or the ice cream example that I gave you, number of broken cones. We can have 0 broken cones, 1 broken cones, or 2 broken cones, right? So as long as it's something that can be counted, that random variable is called discrete. The next type of random variable is called the continuous. And so it is something that can be measured. So if it requires you to use some kind of measuring tool, then that random variable is a continuous random variable. So for example, the height of a person, so normally we round it up to 1 decimal places, but if your ruler is very accurate, it can actually give you 2 decimal places or even more. Or for time, we can also measure time. So 45 minutes is something that we can measure, right? But more accurate clocks or more accurate time measuring tools will be able to give us more accuracy, higher accuracy. Okay, so in general, if it's something that can be counted, then that random variable is called the discrete random variable. If it's something that can be measured, then it is a continuous random variable. In this class, we will only focus on the discrete type. Okay? So let's look at discrete random variable a bit more. In order for us to understand the discrete random variable, we have this thing called the probability distribution. So probability means it has something to do with chance. Distribution means how, sort of like a pattern that shows the outcomes. Right? So a probability distribution is simply, it can be a table, it can be a graph, it can be a formula, and regardless of which form we have, the probability distribution gives us the probability of the outcome. Okay, the probability of an outcome. Let's look at an example. Let's say today I flip a coin, a fair coin. I flip that twice, and I record the outcomes. So we can have a total of 4 possible outcomes. Right? We can have a head the first time and head the second time, a head the first time, a tail the second time, a tail the first time, head the second time, or I can have a tail and a tail. Right? So these are the 4 possible outcomes. Now I'm going to introduce x as my random variable. My x represents the number of heads. So I'm just counting the number of heads. Right? My x, in this case, I have 2 heads, so I have 2 over here. In this case, I have 1 head. In this case, I have 1 head. In this case, I have 0 head. So you guys have seen this table. If you watched the previous video, you guys have seen this. You guys must have seen this table. So my x represents 2. That gives me my x can be 2. That's this one. My x can be 1. That is ht. My x equals 0. That's my tt. Now, this is not a probability distribution. Right? This only tells us the possible values of x, the possible values of my random variable. This is not the probability distribution, since we don't have any probability here. Okay? So, what we have in the second row, this is the probability distribution. Please pay attention to the math notations. Okay? So this is the probability when my random variable is equal to the values of x, lowercase x. Let me say that again. This is the probability when my random variable is equal to these values on the top, the 2, the 1, and the 0. Okay, so the first one, it will say, what is the probability when you have 2 heads? Right, when your number of heads is equal to 2. That's this one. Right. How many outcomes do we have? 4. So 1 out of the 4. That's how we got this probability. Okay, let's move on to the next one. What is the probability when your random variable is equal to 1? In other words, what is the probability for you to have 1 head? So 1 head, this one, another head, well, 1 head, that one as well. So we have 2 out of total of 4 outcomes. What is the probability when you have 0 head? That's what this is. When my random variable x is equal to 0, what is the probability when you have 0 head? That will be your TT, which is 1 out of 4. So, by now, you guys should be able to create tables that shows the possible values of your random variable x, and also the probability distribution for your random variable. Please feel free to rewatch this section of the video. This is very important, okay? Alright, now, a few rules for random variable. They're not new, they should not be new, because we kind of talked about these rules when we first learned about probability. So, for any random variable x, the individual probability for the outcomes should be between 0 and 1, including 0, including 1. So if we look at the previous example, when we have 2 heads, it's 1 over 4, and 1 over 4 is within this boundary. 2 over 4 is also within this boundary. 1 over 4 is also within this boundary. Okay, so the respective probabilities has to be between 0 and 1. The second property here says that sigma notation. Sigma means we're adding up a bunch of stuff to get the sum, right? So the sum of all the probabilities should be equal to 1, and this is always true because 1 represents 100%. Right? So when you add up all the respective probabilities, you should get 1. So let's see. Probability of my 2 heads, my random variable x is equal to 2. This means 2 heads. That's 1 over 4. Plus probability of 1 head. This is over here. Probability of 0 head. That's 1 over 4 as well. So 1 over 4 plus 2 over 4 plus 1 over 4. That gives me 1. Both of these properties, they should not be new, right? Because we actually learned about this when we first came across probability. But anyways, just keep this in mind because sometimes they could be very useful when solving questions, such as this one. So please pause the video and take a look at the information that's been given to you. Okay, welcome back. Now, we have a random variable x, and then it says that the probability distribution is given in this table. However, there's no context. We're not talking about number of heads. We're not talking about number of broken cones or whatever. There's no context here, but that's okay. For part A, they want us to find the value of c. Okay, so all the probabilities that's been given to us they're not numbers. They're all in terms of some c, right? So we need to find the value of c. And for part B, they want us to find the probability when my random variable is greater than equal to 4. So greater than equal to 4, which means 4 and 5. So let's do part A first. The sum of the probabilities should be 1. That is one of the properties that we learned, that we just talked about. But we also learned about this when we first came across probability chapter. So if I add up all 7C, 5C, 4C, 3C, and C, if I add them up, what should I get? Think about it. If I add them up, I should get 1, because these are the respective probabilities, right? So 7C is when my random variable is equal to 1. 5C is the probability for my random variable equal to 2. 4C is the probability when my random variable is 3, so on and so forth. Right? So when I add up, when I try to find the sum of the probabilities, I should get 1. And then after we set that up, everything else is just algebra. So my C is equal to 1 over 20. That's it. Now for part B, they want us to find the probability when my random variable is greater than or equal to 4. So which means we're talking about this part and this part. Right, so we can have P of x is equal to 4 plus P of x is equal to 5. X equals to 4 is 3C, and we just found that C is 1 over 20. That's how I get this 3 over 20. For 5, the probability for x equals to 5 is just C, so that's why I have this 1 over 20. If you add that up, you get 1 over 5. And that's it. So, these two properties here, they're not new, but they are very useful. Okay, so just keep that in mind. And that's it. For now, you guys should be ready to practice on these questions. I'll see you guys in the next video. Hope you guys find this helpful. Bye bye.